Greetings friends, in this short little video we want to show you how to use VassarStats.net to do a correlation matrix. To do a matrix, you go ahead and go to the VassarStats.net website, correlations and regressions, and we want to use the matrix of intercorrelations. So we'll show you what a matrix is in just a moment. We want to use the version 1 because we're going to import data from a spreadsheet. We click on that and we get this dialog box for the data entry. Now we can go ahead and enter data one by one, or we can enter our data in a spreadsheet, which is what we did here, and import it quite easily from the spreadsheet into the dialog box. Now what I wanted to do is see the relationship between the final exam score on a test I gave in a class, and the hours of study that a student might have put into the studying for the exam, their GPA, the pages of collateral reading, the score they received in the pretest, and the score they received on the final exam. So we click on the upper left-hand corner, scroll down to the lower right, Control C or Edit Copy, click here in the data entry and paste it. Then you just hit calculate and you get this matrix box. And what this does is it compares all the variables with each other. So variable 1, which is in column A, hours of study, is compared to variable 2, which is in column B, GPA. Column 3 is pages of collateral reading. Column 4 is pretest. Column 5 is his score. So you can see that hours of study has a moderate correlation to all three of these variables, but what I'm most interested in is this, how it compares to the final column, the score. So hours of study has a moderate correlation. Variable 2 GPA has a moderate correlation. Variable 3 pages of collateral reading has a moderate correlation. But variable 4, the pretest, has the strongest correlation, 0.907. So we might want to further investigate that. We can investigate other ones as well, but for our purposes we're just going to dig further into these two. Now because this is a very simple program, you're not going to get a lot from this matrix except indicate where to go next. So we're going to go ahead and just copy the data from these two columns here, and we want to compare them to each other. We go back here to the correlation and regression page, and as I showed you in a previous video, we're going to go to the basic linear correlation, data import version, and looks like I got the wrong data there. Let me go back here and just copy this. There we go, and calculate. And remember that 9.907 number in the matrix? Well, there it shows up again. And so we know that that's, again, a strong correlation between the pretest and post-test. We go here to the p-value. It's a one-tailed test we're going to be using, the one-tailed number we're going to be using, because we know it should be a positive correlation, so we're going to use the one-tailed. And here's that confidence interval. So we know that's in the mean for the entire population. We just have a sample of it, but the mean for the entire population is, we have 95% confidence that it's between 0.79 and 0.95. So this number here would fit right in the middle of those two, the upper and lower limits of the confidence interval. So that's how you conduct a correlation matrix, and then to do a little bit of further investigation, how do you use the basic linear correlation to be able to dig a little deeper.